We are looking at the effect of temperature on Kw and on the pH of pure water. And we're going to start with some information, and I'm going to put a star beside it, because it's really important information. And you're going to think, oh, it's so obvious. I know this already. A solution is neutral when hydrogen and hydroxide are the same. A solution is acidic when you have more hydrogen. And a solution is basic when you have more hydroxide. And you're like, why are you telling me this? It is so simple. And yet, by a magic trick, I will make you forget this by the end of this lesson. Ooh. You might not believe me, but it worked in period 3, so we'll see. Okay. First of all, pure water. Why does pure water have a pH of 7? Well, to be honest with you, this question is a little bit misleading. Yes? The reason it's misleading is that the pure water has a pH of 7 only at 25 degrees Celsius, which is the temperature at which the Kw is 10 to the negative 14. What do you know about K values and temperature? Yeah, if temperature changes, K values change. Is there anything else that can change a K value? Nope, just temperature, but temperature will change it. Now, let's do a little bit of math here. So to find the pH, you need to know the hydrogen ion concentration, yes? What formula would you use to go from hydrogen to pH? pH is equal to negative log of hydrogen, because the P part means negative log, yes? So before we can find the pH in pure water, we need to find the hydrogen. Well, we know that Kw is equal to the concentration of hydrogen times the concentration of hydroxide, yes? Okay. And we know that at 25 degrees Celsius, that's its value. 1.00 times 10 to the negative 14. Now, because this is pure water, we know that concentration of hydrogen is equal to what? Because it's pure water, hydrogen is equal to hydroxide. Remember that, okay? And if that's true, well, it has to be true, right? Because if I have water and water splits apart into hydrogen and hydroxide, for every 1 hydrogen, you're going to get 1 hydroxide, yes? If we write, that's our simplified version of that equation. The more realistic version of that equation has a water reacting with a water, and one water gives a hydrogen to the other water. But regardless, we still have that 1-to-1 relationship between hydronium and hydroxide, or hydrogen and hydroxide. Do you remember what we call this process that's happening here? This is the autoionization, yes. Are you finding everything okay, Ben? Yeah? Okay. Just heard a lot of pages. Okay. Not that you're probably ever going to have to write like auto-ionization of water, but you could be asked to write the equation for the auto-ionization of water. And if you don't know what that means, it's going to be a pretty tough question, yes? All right, because these are one-to-one and they are equal, right? Hydroxide equals hydrogen. What that means is we can actually take hydrogen and put it in the place of hydroxide because the two things are equal. Yes? So what that means is I can rewrite the equation. Instead of hydrogen times hydroxide, I could write it as hydrogen times hydrogen, yes? Which would give me hydrogen squared. And that's equal to Kw. Okay? At 25 degrees Celsius. There we go. Okay. So if I wanted to then solve for my hydrogen ion concentration, all I would need to do is take the square root of that, yes? And the square root of 1 times 10 to the negative 14 is 1 times 10 to the negative 7. And remember, hydrogen and hydroxide in pure water are the same, okay? Those two are equal to one another. So hydroxide ion concentration is also equal to 1 times 10 to the negative 7 molar. We were trying to find pH and pOH. So we're just going to use our pH formula and our pOH formula. So we are going to take the negative of the log. Okay, so let's do that. Here's our pH. Okay, we're taking the negative log. Here's our pOH. We're taking our negative log of OH. Those two values are the same. And so in both cases, the negative log of 1 times 10 to the negative 7 is 7. So that's where that very famous, very familiar neutral water is pH 7. That's where that comes from. Okay? Now remember, this is all at 25 degrees Celsius. Now we're going to look at what happens to Kw when we start messing about with the temperature. So we have this table, and you'll want to refer to your own because you'll be able to actually read it and see all the values. As we go down the table, what is happening to the temperature? Temperature is, everybody, increasing. Yes? What's happening to Kw as we go down the table? It's also getting bigger. So as temperature increases, the Kw is also increasing. So we're going to write that down in our first little question here because it'll be useful information. As temperature increases, Kw increases. Now, do you remember what Kw is? Kw, what's the formula? Tell your partner, what is the formula for Kw? Kw is concentration of H times concentration of OH. So this value got bigger, yes, when we increase the temperature. Now, if we write the auto-ionization of water, and I'm going to write the simplified form because why not? If Kw has gotten bigger, which way has the equilibrium shifted? Left? So if it has shifted left, that means I have more water and I have less hydrogen and less hydroxide. Would that give me a bigger Kw? Yeah, it has to have shifted to the right because I have now more of these, which makes Kw bigger, yes? So the system has shifted right. So where's the heat term? Yeah. And if the heat term is in the reactants, then the reaction, the autoionization of water must be endo or exothermic. So we're going to write in our heat term here in the reactants. So that is endothermic. Yeah. So that's how you can logic your way through that one. Okay? Could we write a formula for how to calculate H3O plus? What could I say instead of H3O plus if I wanted to? How could we find the concentration of H in pure water? Sorry? Okay, so we have H from the equation for Kw. But do we know the concentration of hydroxide? No. How do we calculate the hydrogen ion concentration in pure water? Oh, look what we did back here. We calculated the concentration of hydrogen in pure water. This calculation, this substitution, where hydrogen is equal to hydroxide, is true at all temperatures for pure water, not just at 25 degrees Celsius. So at all temperatures, you can say that Kw is equal to the concentration of hydrogen times the concentration of hydroxide. But we know that hydrogen is equal to hydroxide, yes? And therefore, Kw is equal to H plus squared. And so if we wanted to know the hydrogen ion concentration, what would we do with our Kw? We would take the square root of Kw. Yeah? So this is true for all temperatures for pure water. The only thing that's not true is that Kw isn't equal to 1 times 10 to the negative 14 at other temperatures, okay? But if we use just Kw instead of an actual number, we are okay. All right, back here. So we can put that into our thing here. We can say H3O plus or H plus is equal to the root of Kw. What is true about the hydronium and hydroxide ion concentration in pure water? They're the same. They are equal. So now that we know that, we can actually go back and fill in the rest of the table. Yes? So I want you to start by filling in the hydrogen and then fill in the pH, and then you can do the hydroxide and POH, okay? You do it and I will do it as slowly as I can, and you can check your answers with me when you've done it, but try the calculations yourself, okay? So you're going to use the fact that hydronium or hydrogen is the root of Kw, and you know the formula for pH, negative log. If you've done those first hydroniums, did I do my calculations right? Did I get my numbers right? Yeah? Excellent. Okay, I'm going to try for my pHs now. Did I get them right? You don't have a calculator. Do you have a phone? You know what? I downloaded an app. It's called Calctastic. It's actually a scientific calculator, and it will give you a real scientific calculator on your phone, as opposed to whatever nonsense that they give you with your phone that is like for elementary school, right? Yeah. Okay. So if I know these values, it looks like I've got a lot of work cut out for me to fill in my OHs. Boy, oh boy, that seems like that's going to be a lot of trouble. Is it? Is it going to be a lot of trouble for me to figure out my concentration of hydroxide now? Oh, it's the same. So I'm going to write down a few of them just to prove to myself that they are the same. Yes. -8, 5.41 times 10 to the -8, 8.25 times 10 to the -8. And now I'm just going to write that they're equal all the way down because I don't want to write all that stuff. That's a lot of writing. How about our POH? Oh my gosh, it's the same. So I'm going to do the same thing. I'm going to write down a few just so I notice the trend. 7.267, 7.084, and now I'm just going to write these are equal. That way I don't have to write so much. All right, and now I'm going to do my magic trick, and the bell might ring in the middle of my magic trick, so I'm sorry. Okay. So at temperature 50, my pH is 6.631. So at 50 degrees, my pH is 6.631. That's for my pure water. Is that acidic, basic, or neutral? Acidic, basic, or neutral? My magic trick worked on you. But it did not work on you. It is neutral. Why is it neutral? Because, let's go look. My concentration of hydrogen, whoops, not that one. My concentration of hydrogen and my concentration of hydroxide are the same. It's just that neutral pH is only 7 at 25 degrees Celsius. You remember how I was always like, it's only 7 at 25 degrees Celsius, right? But the magic works. Yes, this is neutral. But we are so programmed into thinking that 7 is neutral that we see that and we're like, oh, it must be acidic. But the key is that it is pure water, and therefore hydrogen is equal to hydroxide, and therefore it is neutral, and actually neutral pH at 50 degrees is 6.631. Thank you. Alrighty, and that is it. You are going to work on 4.2a and 4.2b. Anything you have not done on there, practice those. If you're really good at that, you'll probably do most of the stuff on the quiz on Friday really well. We're going to finish up with this mañana, tomorrow, and then 4.2e is like just applying it to like strong acids and strong bases. What? Thursday. Don't forget, quiz on Friday on 4.2. I will have tomorrow's lesson recorded if anyone wants to watch it ahead of time. If you're like, I don't want to learn something the day before my quiz. Okay? What? You're having your quiz on Friday. Otherwise, you have to remember stuff all the way through the break. Not that you don't have to anyway. I don't know. I don't know anything.